I think last time we have landed on this slide, which we just talk about intermediate code generations and how the emission is happening here on this slide. Is that right? Okay, great. So we have talked about the code segmented rows sequentially, and we want a temporary variable or global variable as a code list to store all the codes we are generating. Why we want to do that, and we are talking about that in later of the slides. And we know code segment code instructions is grows sequentially as the more P code instructions are produced. And this process is the foundation of our intermediate representations, the virtual instruction list that will be later be executed for your PM0, the virtual machine. At the bottom, you can see this sample source statement that is A becomes B plus C. That's its compilation will eventually produce a sequence of load, store, arithmetic instructions, and in the same way. So we have talked about in this lecture, we are considering the data structure we're dealing with is a 1D array or 2D array in the lecture. 2D array, 2D array. But in your homework, what is that? 1D array, okay? Just be mindful of that. So we understand that how the code is being generated and placed in the code segment or being placed in a global variable that is called code list. So how we actually do that is through a function called emit. Okay, here is a function emit function for the pseudocode. Emit is responsible for constructing one instruction at a time and storing it as in a code segment or the code list. The function takes the three parameters: the opcode, which is OP, the operation code, L, lexicographic level or lexical level, and M that acts as a modifier or operate depending on the operations. So inside this function, we are going to first check if the CS, the current CX or current index location or the code index has exceed the predefined code size. That is what we have for the entire lecture or entire class is building on the static array. You can think is what do you have in your homework one? How many elements we have initialized for the array? 500, right? 500 is sufficient enough. But in your code list, you could also have a 500 static array to hold all the instructions, okay? But if you do have some kind of dynamic memory, allocated memory, or some linked list for the emission, you don't have to do the if statement checking here. But if you do have a static array, it is a good idea to have error prevention in case it is out of the boundary. Okay, out of boundary could cause significant damage to your memory. So we don't want that. Just be mindful of that. You want keep in a safe range. All right. So if it does across the code size, we are going to trigger the error 25, as you can see, to signal the code is overflow condition. And what it really does is we normally want to go into restrict how many codes or instruction we can generate. So in our instance, again, it is 500. You can also initiate 500 array, static array for your homework 3 to hold all kinds of instructions. Okay? It can be 2D, it could be 1D, just depending on your implementation. Then coming back to here, this code, once we pass okay, now we have everything online. And so if the code list, the code index is less than the code size, we store each field as here, it will be text cx or .op is equal to the passing parameter operation code and lexicographic level modifier and cx plus 1. But you have to think of this one is for the implementation that we consider the data structure is a 2D array. But once we modify this entire instruction into a 1D array, what will happen? What is the pseudocode will like? What parts we are going to change? Are we going to change this part or this part? Second part. And are we going to change all the instruction in the second part? Yes or no? Yes, we are going to change everything in the second part. So how are we going to change it? Is the first instruction going to be changed? It can be changed. It can. It means if we are going to change it, it could be text cx plus 0. Plus 0 basically changes to nothing, but plus 0 for uniformity. But for the next one is what? Text cx plus 1. And next is cx plus 2. And finally, we have cx plus to be what? Cx is equal to cx plus 3. Okay, that is changing the 2D dimensional structure to be a 1D data structure. That's how the implementation happens. Okay, you have to consider carefully in your homework 3, as your homework 1 input is only considering 1D array. Okay, I have to make this difference. All right, now we move to the pseudocode of our expression to the terms, and that is the grammar on top is saying the term is one factor, is made of one factor followed by 0 or more repetitions or stars to symbol or multiply symbol or slash symbol or divide symbol and another factor right here. It encodes operator precedence as multiplications and divisions bind tightly, then the plus or minus we handle in the expression. That's why it is in a lower tier comparing to the plus or minus symbols. The pseudocode is exactly mirrors the rules 1 2 for 1, 1 for 1. And first we parse the factor. So once we get into the term, first thing we are going to do is calling the factor function. As you can see here, that is directly mirror what we have for the grammar. And since we have a curly bracket, means we need to implement a while loop for that curly bracket. For this curly bracket, we know the current token, we have to check the condition. What are the conditions we are checking? This is the condition, multiply symbol or divide symbol. Is it multiply symbol or divide symbol? Yes, it is. Then we get into the loop. If not, we're jumping over the loop. It means we are matching 0 times. Here, while loop matching more times. Okay, getting into the loop, we simply record the current token. It could be multiply symbol, could be slash symbol. We just record the current token as it is very useful for our generation, code generations. Otherwise, we just cannot generate the correct instructions for our symbols right here. We always know we have to load information first, then perform the operation secondly. That is why we are recording the operation here. So getting next token will be proceed into the factor. The factor is here from this grammar. Okay, the factor. Once we coming back from, we don't care what the factor does. It can be loading anything, loading or lit or doing something some other expressions. We don't really care. But once we coming back from the factor, then it is our job to emit the correct instructions based on the operand we have, the opcode. It could be multiply symbol, could be slash symbol. Then we are going to initiate or emit the correct instructions. Could be OPR 0 multiplications or OPR 0 division instructions. That is purely from your homework 1 instruction list. Just consult that homework 1 instruction list. Now, have you seen this as 1-for-1 translation from the grammar to the pseudocode? It's actually matching. So be careful your homework 3, as the pseudocode is not 100% accurate to the grammar, okay? Then here we are just translating the if condition and then statement. That's the grammar we're dealing with. And once we're talking about how this grammar is translating precisely in the pseudocode. So the first one is if condition, and we're checking if that's the if symbol we are dealing with. Yes, then we proceed to this block. And get to next token, we are invoke condition, invoke condition, and then we're coming back from the condition. We are going to check if the current token is then symbol, the reserved word. If yes, no problem. If no, we are going to raise an error telling them that we are expecting a then reserved word, but you are missing that. That's the error. So we are going to stop right here, raise an error message. All right. So if that is an then symbol, we are proceeding to the next one. That is grab the next token. And here, the funny thing is we are going to record the current emission or the CX, the current CX here to make sure if we have anything to refer back to. That is why we want have a variable token list, a code list in our Homework 3 implementations. Then we are going to emit JBC00, and then we are going to call or invoke the function statement. This function statement is directly from here. And lastly, we are going to update. We will talk about this one step by step. Then you will see why it is very useful for a token list to be a global variable and or the data in your implementation rather than directly emit the instruction to the terminal or save it to a file. Okay, so now we land into this part. We are processing A become B plus 5. That is the thing we are processing. And here we are recording that index. CX is basically here with CX, CT temporary variable is recording the CX. Now we are emitting the first instruction, JPC00. What is happening to the JPC00? Why we are initiated JPC00? Lexicographic level doesn't really matter for the JPC instructions, but the M really matters. We're initiating the 0. What is 0? Is it fake address or something else? What? Nobody? It is a fake address. It is a fake address. You can emit JBC 0, -1, JBC -2. It doesn't really matter because we eventually going to update that modifier to be something that is actually presented in our code list. Okay. And then first we emit that JBC 00. And the real target for the address immediately after the then part, at this stage, we simply do not know until the then part is being processed or this part is being processed. Okay. Then we go to the statement. Statement is generating a whole bunch of that instructions. Do we care about they are generating them in this stage? No. That's why we are dividing the roles or dividing the responsibility. Whoever handles the statement code generation, it handles that. Whoever coming back from the if statement, we handle that if statement code generations. It's just dividing the responsibilities. And the statement is generating load 04, that is loading that number, lit 05, lit that number, and adding, doing the addition, and then pushing back to the store, that is A here. Then we're coming back from the statement, and we know the current CX, the current token next available slot for the instruction to be inserted in the code list will be this slot. And we know now our JPC will going to be jump to this instruction, this instructions. That is this back is called back patches. That is back patches to the jump in target, the JPC with JPC0CX, meaning we are popping the Boolean, and if it is 0, we are going to jump in the instruction at index CX. That is the first slot after the then part. Okay, that is why we want a global variable that code list to hold all the instruction we are emitting. We are not directly emitting to the file or terminal, as if we're emitting that, you're basically fixing the JPC00. But JPC00, that M, the modifier, we still don't know until we parse everything in the then part. Get it? Great. All right. So now you know why we want a code list and how is the JPC is jumping or updating its modifier based on what we have this pseudocode. Now we're coming to this while condition and do statement. The while rule uses very similar backpatch pattern as if, but with an extra jump to repeat. So first we save the CX1. Whenever we are doing the condition, we are going to save the CX1 as our JPC condition. And then we advance to this part, that is CX2, okay? Then we're doing all kinds of statement, whatever the statement we do. And lastly, we are going to emit JMP0CX1. We are jumping back to the condition. That is how while loop is doing its job, okay? Any question? Yes or no? Do I need to repeat myself? If not, let's proceed. So on this slide, it just explains how we transform the grammar condition, odd expression or expression relational operations and expression to a precisely matching pseudocode, okay? So here into the condition, it means whenever we have a non-terminal, we need a function for the implementation, not something else. A non-terminal means a function. So it means for the condition, we have a condition function. Inside the condition function, we have to check, is the current token is our symbol? If yes, then we're getting into the if statement part. That is, grab the next token, invoke expression here, and emit 206. That is specifically for this lecture. It's not the same to your homework 3. We are emitting 206. That is the odd instruction. Okay, then we get into the next part. That is else or the or part, that expression, relational operations, and expression. Getting into the else, the first thing we are going to do is invoke expression. That's basically this grammar is telling you. And once we have the expression, we get into the expression, checking if the current token is in the relational operations. What are the relational operations we're dealing with? Equal, less, not equal, less equal, greater, greater equal, 6 different elements we're doing. Those are all relational operations. So we want to be explicit about what kind of relational operation we are currently doing. But of course, you can, in your homework 3 implementation, you can write an array that's simply doing the while loop array. That's checking if the current token is in that array or not. That is your implementation. I have no comments at that, but it's just very slow. If you are just doing the if statement here, it's kind of long, but it's very efficient. Okay, so once we check if that token is equal to a relational operation, good, we are proceed. If not, we are going to raise an error and stop right there. Okay, now we're getting to the relational operation part. We are checking, okay, the current token, we are going to record the current token, that relational operation, grab the next token, invoke expression. And once we're coming back from the expression, we are going to emit the instruction based on the relational operations. Okay, so that is the idea. We always want to emit the instructions at the very end. Okay. Now, what we have here is a very good representation about how your code is generating instructions. And this slide is telling you how you can use identifier equal to expression data assignment statement to generate any instructions. So you don't have to consider this one. Let's talk about just using this example to talk about how your grammar is performing overall. So we're all coming back to the grammar. And what I'm going to ask you to do is here is you can either take a picture of this example, or you have the slides, just using that slides on your laptop to review that example. As I will jump back to the grammar to tell you how exactly the grammar is processing the entire example here. Okay? Everybody got it? Great. All right. Now we're landing on this grammar, E, B, and F. So once we receive, even in your homework 3, we have received this input file, variable A, comma, B, semicolon, and etc. What is the first thing you are going to do? Your homework 3 is doing. Yes.
The Lex code to make tokens into that file.
Yep, makes a using the lex.c and putting into a token list. Great. So what exactly the input file we are reading for token for your parser code.c? That token file, right? That token file. So based on that, how you're going to transform the input file? So you're going to be the first element in the token list will be the var symbol, then we have a 0, 0, 2, or 2, and A, comma symbol, 2, B, semicolon, semicolon symbol, or semicolon token, or the next one will be 2A, become symbol, 2A, plus symbol, 2B, and period symbol. That is the complete token list you are dealing with in your homework 3 actual parser code generations. Okay, now you have a great understanding about what we are dealing with, the token list. So based on the token list, the pointer is pointing to the first element in your token list. What is that? The var symbol, right? The var symbol. So it is pointing to the var symbol right now. Now, what is the first entry, the first function we are going to call based on the grammar? Not block. Yes. What's that? Oh no. The first function after receiving that token list, the first function you are going to call. Yes. Great. Program. Okay. Program is the first function your implementation need to call at the very beginning. Okay, program. Now, inside the program function, we will have the first element will be still pointing to that first token. And we are going to call block. Then if we don't care about whether we're coming back from block or not, just consider we are calling the block. Okay, now we're calling the block, then we're landing on, let me have a pen for you. We're calling the block, it means we are calling this part. Then we are going to do the constant declaration. We have to call constant declarations. Once we go to the constant declarations, it will check if the current token is equal to const. That is if statement, checking that. Our current token is what? Var symbol. Is it equal to const? No. So it means the entire constant declaration will be getting jumped over. We will reach the very back here. So basically nothing being processed in the constant declaration. Okay, now we know that, and we are coming back from the constant declaration, and we are getting to the next step, which is the variable declaration. Okay, important. Variable declarations. Getting to the variable declaration. The first thing we are going to do is checking the if statement is true. if statement, if the current token is equal to var symbol? Yes, it is. Yes, it is. So we get into that if statement. Now, the next token, we'll grab the next token. Next token is what? 2, right? 2 is our identifier token. Identifier token. We are expecting identifier token. No problem. So that is if statement, checking that satisfied. If that's satisfied, grab the next token. Next token is what? It's A. It's A. A, the variable A, the name A. Then we grab the next token that is name A. In this case, we have that information. And we need to insert that symbol into our symbol table in this stage. Okay, insert that symbol into our symbol table. Our symbol table requires a couple different attributes for that symbol. First, we need to record the name A. A is directly from that token list. A, level 0, correct. Level 0, because we're currently in level 0. It is a global variable. Address. Consider your homework 3. Address. Who said yes?
Would be the file name like token list.txt?
Nah. Address is 3. You got it correct. Address is 3 because we are considering the activation record, not the directory of the input file. Okay, it's 3 right now. And what's the type for that symbol? Variable 2, the variable is the type of variable. And lastly, we have the mark. What is the mark? 0. Now we have successfully created entry in our symbol table for variable, the symbol A. Once we coming back from the insertion of symbol table, we simply grab the next token. Our next token is comma symbol. Okay, comma symbol. And as you may see here is the curly bracket. Curly bracket means we are going to have a while loop condition to check the first element in that while loop. What is the condition we are checking? If the next symbol is comma symbol or not. What do we have here? Our current symbol is comma symbol. So we get into that while loop. And the while loop, we are doing a very similar procedure. Grab the next token, that is 2, and grab the next token. Okay, since we have identifier, grab the next token, that is B, right? Then for that B symbol, we are going to insert that symbol into our symbol table to create additional entry in the symbol table to be, the type is variable, the name is B, the level is 0, the address is 4, and the mark is 0, correct. So we have successfully created an entry, additional entry for B. How many elements we have for the symbol table? 2, A and B, right? Okay, now we coming back to this part, and we check, we have inserted that B into our symbol table. Good. So checking, grab the next token. Next token is semicolon in your input file, semicolon symbol. But we still need to go back to the while loop to check if that's semicolon equal to the comma. Nah. If it is not, jumping over to this one. And we're just checking if the current token is equal to semicolon. Yes, it is. So grab the next token. Next token is two. And next token is 2. We grab the next token. The current token is 2. Okay. So variable declaration finished its job, and we're coming back to this part. Okay. Coming back to this part, and we are going to proceed statement. Calling the statement function. Getting to the statement function. It is a huge implementation. It will be a huge implementation as we have to decide what is the current token type. If it's equal to identifier, we are going to use identifier the assignment implementation. If it's going to be begin, it will be using begin. If it's if, we're going to if, and then while, using while. If nothing happens, default case is doing nothing. That is epsilon. Okay, so the current token is 2. It means identifier. So the part we are going to use is identifier become expression. That is the part we are going to use. Okay, so identifier is identifier, no problem. Grab the next token. Next token is A, right? Are you following me? A. So once we coming back to the A, it means we are landing in the statement. It means we are going to use the declared A. We are no longer inserting any symbol into the symbol table. And we are going to use the symbol from the symbol table. So it means we have to check if that A exists in our symbol table. If not exist, we have to raise an error telling the user, it never been declared before, how you can use it. Okay, then we have to use that information. We are searching from the back to the front. The first element we are searching is B. Is B matching to A? Now, move the pointer to the previous one. Is A matching to A? Yes, we are. Okay, we are matching to A. A is having a level of 0, but we have to also check, is the current level is 0, is smaller or equal to that record level. 0 less equal to 0, true or false? True. So therefore, we can use that symbol. But one more condition we need to check. Is the current mark for that A in the recorded symbol table is being 1 or not? If it is 1, it doesn't really matter we have the level to be smaller or equal to the current level or something else. It means we cannot use it. Is 0, it means we can use it. Is 0 or 1 in the symbol table? It should be 0, right? So we haven't changed anything. So it's 0. It means we can use it. Okay, we have checked. A is a valid entry in our symbol table. A is usable in our symbol table. It means we can proceed to that. No error happening right here. That is the symbol table lookup step. You have to be careful about that. Then grab the next, yes. Yeah, the current level should be less than the recorded level, okay? Then we have next symbol, we grab the next symbol in our token list. Next grab symbol is become symbol. If you still remember that one, that become symbol. The become symbol is become symbol, which we are checking here, that if statement is checking it. Okay, it is. So grab the next token. Next token is 2. Okay, we haven't processed yet. So we get into the expression, we are calling expression. This one, calling expression, getting into that. If the current token is 2, it's nothing related to the plus symbol or minus symbol. So we skip this if statement, skip that. We directly go to term. Go to term, we're checking, okay, we haven't processed anything, we're directly invoking factor. In the factor, so factor means we have a huge chunk of code that is checking if the current token is equal to identifier or equal to number or equal to open parenthesis or not. So we only having satisfied one condition. The condition is it is identifier. It is identifier. 02 is identifier. Then we grab the next token. Next token is A. Then we have to check if that A is valid in our symbol table or not. Valid, of course, we haven't changed anything. We check that is existing in our symbol table, and then we know it is valid entry we can use. Then we emit instruction for loading the value of A. What are the information we are loading? It is a load level coming from the symbol table. The recorded level for A is 0. But you have to understand that loading is mean we are loading the level relatively to the current activation record. It means we have to load recorded level minus the current level. It should be current level minus current level minus the record level. So it's still 0 minus 0, and in this stage is 0 minus 0 is 0. Okay. Then we have to have another thing is we're checking the address of the A. It's the address of A is in the recorded symbol table. Just simply grab it. It's 3. So we are emitting the first instruction is load 0, 3 for A. Then we grab the next token, and we are finishing the factor. Of course, here we're getting back to here for whoever called us. And we're checking if the current token, the plus symbol, is multiply symbol or division symbol. Not really. So finishing its job, finishing the term job, coming back to here is while loop. We are checking if that token, the plus symbol, it is plus symbol. Getting into the while loop. Grab the next token, and we are following the same step. That is, go to term, go to factor. It is identifier. 02 is identifier. The token we're dealing with is grab the next token is B. We're using a very similar pattern. Using that B, go to the symbol table, check if that symbol is being recorded in the symbol table. Yes, it is. Is the entry valid that we can use? Yes, it is. So we are generating the instruction. It will be load relatively lexicographic level 0 minus 0 and address from the symbol table. Address is what? 4. So it will be load 0, 4 for our instruction. Okay. Now load 0, 4 is being generated and it's finishing its job. We're grabbing the next token, which is also the last token we have for the entire token list. That is a period symbol. Okay, the period symbol, we're coming back from the factor and go to the term, checking the period symbol is multiply symbol or division symbol. Not really. And it's finishing its job and coming back to here. And we are going to check the while loop condition. If the period symbol is equal to plus symbol or minus symbol, not really. Jumping over everything and it's finishing its job. The expression is finishing its job. And we are coming back to here. It is telling you, okay, at this stage, I have to initialize a instruction that is for the storing. We have done the operation that the OPR02, that's for addition, which is generating here. Okay. Now we are coming back to the expression, and here we are dealing with what? We have the A is being storing that information. We have to emit the store. Store level is 0 minus 0, relative level is 0. And what do we have for the address? That's because we have A. Address is directly from symbol table is 3. Store 0, 3. That's the instruction we are generating. And once we're finishing this job, we're coming back to here. Nothing will be processed. The current token is still period symbol. Okay. So coming back from whoever called us, which is the last statement we are doing. Period symbol is period symbol. No problem, no error. Finishing the job. Now we have successfully checking the syntax of the input file is legitimate, and we have generating 4 instructions. Load 03, load 04, OPR 02, store 03. That's complete assignment for our input file. Get it? That's basically what we are going to talk for today's session. And let me tell you, so a lot of you tell me, the things is kind of vague, something that I didn't represent in the class. I cannot give you a lot of visual stuff as the slides is lack of explanations. You have to rely on my lecturing, but we do have recitations that help you to understand. You can go visit recitation 7, the PDF and the recorded videos. That is very helpful for you to understand step-by-step visualizations. And you can directly go to here, simple example, telling you what is the current token if you are dealing with X become A semicolon, okay? What is the current token? And what is I, what is the symbol table we are dealing with is only recording a very simple version, that is the type, the level, the address, okay? And the recurrent stack is telling you what is the current executing function and who is calling which function and etc. As you can see here, at a very bottom here and here. The current execution function is expression, and we are indeed in expression, and statement is the one calls expression. Okay, that will be more visual stuff for you to go review. All right, that'll be it for today. So if you have further question, please ask, okay? If not, you may dismiss.